Hey guys, here's my slope intercept video version 2. Hopefully works okay. We're looking at the slope intercept form of graphing a line. Please don't skip around in the video. It may confuse you. All right, so you guys got some notes from your sub this morning that should look like this. Slope intercept form. In the top corner, we've got the slope is, and that's going to be your rate of change over time. That's your rise, how far up you're going, divided by your run, how far to the right your next line needs to be. You're also going to have a y-intercept, which is where the line crosses the y-axis. Down here on the left, this formula, y equals mx plus b, is going to be our equation for a line using its slope and also the y-intercept. That's why it's called slope-intercept form. So we've got 4 different letters in our equation. Y equals mx plus b. The x and the y are usually just letters, but m and b are going to be different numbers. The m is going to represent the slope. The b is going to represent your y-intercept, or where the line crosses the y-axis. That's the up and down axis. So y is going to be a variable, x is going to be a variable, and you're not going to see numbers there. So we're going to go ahead and apply this to something so it makes a little bit more sense to you guys. We've got some steps for graphing using this formula. So we've got the line y equals negative 3x plus 2. We're going to start by placing a point at the y-intercept. So in our equation, the y-intercept is going to be at the end. It's the plus 2. We're going to put that at plus 2, positive 2 on the y-axis. From there, we got to figure out our next point using our slope, which is negative 3. We're going to be careful about positive and negative directions. So in our example, the slope is negative 3. And that's not a fraction, and we need it in fraction form. So we can remember that any number by itself is the same as that number divided by 1. So negative 3 divided by 1. That means we need to go up by negative 3. That sounds funky. What that really means is we're moving down. We also need to go to the right 1. So our next dot is down 3 over 1 to the right. We're going to put it right there. The next thing we do is connect our 2 points to form a line. So our line is going to go straight through our 2 points. We've got some examples here. It says write an equation for each line in slope-intercept form. So we need to figure out the slope of the line and where it intercepts the y-axis. So in our example here, we're going to see how far up does it go when we go from this point to this point. So if we start at the point on the left, I'm not sure if you can see my mouse or not, we would go down 2 to get to the same line that the second point is on. So that's down 2. So if we're counting how far up we went, that's in the negative direction. It's negative 2. And then we need to figure out how far to the right we went. 1, 2, 3, 4, 5, 6. So we're going to have negative 2 over positive 6. We can simplify that to negative 1/3. So we'd have y equals negative 1/3 x. And then we need to figure out our y-intercept. That's going to be negative 1. Because we go down 1 to get to our y-intercept here. So negative 1/3 x minus 1. Over here on the right, we're going to do the same thing. We need to figure out the slope of our line. So how far up do we go from one point to the second point? 1, 2, 3, 4, 5, 6. And then our denominator in our fraction is how far I went to the right, and that is only 1. So y equals 6 over 1 x. We can simplify that to 6x. We don't need the divided by 1. So y equals 6x. And where does it meet the y-intercept? That's at negative 1, 2, 3. So y equals positive 6x minus 3. Now we're graphing some lines. This one says y equals negative x plus 4, and we don't even have a number in front of that x. We just have a negative sign. So we can assume that's a negative 1, or negative 1 over 1. So our slope is going to be -1/1. So we're going to be going -1. And then our y-intercept is at 4. So we would draw our first point at the 4 and then go -1. So your line's going down. On the right side here, we've got a problem. This is not in y equals mx plus b form yet. We need to fix this problem here with the y plus 1. So y hasn't been isolated by itself yet. We're going to need to subtract 1 from both sides before we can start. When we do that, we're going to get y is equal to 1/4 x minus 1. And now we can graph it. We're going to have a slope of rise 1/4, and our y-intercept will be at -1. We've also got a few special cases where this could look different. In our first one, it says y equals 2x, and what that means is that 0 is your y-intercept. So there's like an invisible plus 0 at the end. So it's going to start at the origin. Our next one is 0 slope when y is just equal to 4. That's a horizontal line where y is equal to 4 at every single location. And our last example is going to be when you've got some extra work you got to do first. Sometimes people give you an equation and it is not in the beautiful y equals mx plus b form, and you got to get the y all by itself before you can work with that equation. So you're going to need to manipulate that equation to get y by itself on one side. You do that by subtracting the 5 and then dividing both sides by 3 in this case. And at the bottom of your page, you're going to have 4 practice problems to work on. If you're reaching the end of class, have your sub write those answers on the board or give you the paper so you can write them on the board. And there's a QR code here. It's also on your whiteboard in your classroom. And you can check out a math lab to see how does that graph of the line change as you mess with those different variables. And if you still finished early, you can color code these notes. Make it a little bit easier for you to understand the stuff on the pages by color coding things like your y-intercept and showing the actual rise and run of your slope. I'll see you guys later.